Germans laughed at Britain's Dustbin gun until it blasted holes through their fortresses. June 7, 1944. Morning. Oberfeldwebel Karl Brenner had learned to trust concrete. 18 months in the same pillbox teaches a soldier what protection means. Not luck, not courage, engineering. 1 meter of reinforced concrete between you and everything the enemy can throw at you. Steel reinforcement bars embedded in the matrix. Firing slits designed by architects who understood fields of fire and structural integrity. Ammunition stored in recessed compartments that wouldn't cook off even under direct bombardment. The position covered the main road through the village, 3 miles inland from Sword Beach. Overlapping fields of fire with the adjacent bunkers. No dead ground, no approach the machine guns couldn't reach. The kind of position that made tactics simple. Let them come, let them die, wait for them to give up. Brenner's squad had held it through probe attacks, reconnaissance patrols, and 2 separate attempts by French resistance fighters who'd tried to place explosives against the rear wall. All failures. The concrete had held. It always held. The British had landed 30 hours ago, and Brenner had watched the chaos from his firing slit with professional detachment. Beaches turning red, landing craft burning, bodies washing ashore with the tide. Spectacular violence, but distant. His concern was the village, the road, the 500 meters of open ground any assault force would have to cross to reach him. Time favored the defenders. Every hour the British spent consolidating their beachhead was an hour German reinforcements moved closer. Every delay multiplied their problems, logistics, coordination, the mounting pressure to break through before the Atlantic Wall became an Atlantic trap. Doctrine favored the defenders. Fortified positions couldn't be rushed. Infantry assaulting bunkers frontally accepted catastrophic casualties, or they didn't assault at all. The mathematics were unforgiving. Machine guns behind concrete versus rifles in the open. No tactical manual in any army recommended that engagement. Artillery could damage bunkers, given time. Hours of preparation, coordinates carefully plotted, forward observers calling corrections until enough shells landed close enough to matter. But artillery wasn't precision work. Brenner had survived 3 sustained bombardments already. The walls cracked, dust fell from the ceiling. Ears rang for hours afterward, but the structure held. That's what 1 meter of reinforced concrete meant. You might be uncomfortable, but you'd be alive. The British infantry appeared mid-morning, moving cautiously through the ruined buildings at the village's edge. Brenner watched them through the firing slit, counting heads, assessing their approach. Disciplined troops, they used cover properly, advanced in coordinated groups, didn't expose themselves unnecessarily. "Range 400 meters," he said quietly. His machine gunner settled behind the MG-42, tracking the movement. Waiting. The British came closer. 300 meters, still using the rubble for concealment, but the open ground ahead would force them into the clear. Standard problem for any attacking force. At some point, cover ends and killing ground begins. At 200 meters, the lead British section broke from the ruins and ran toward a shell crater that would give them a position closer to the bunker line. Fire! The MG-42 opened up with its distinctive sound, not the rhythmic thump-thump-thump of other machine guns, but a sustained roar that German troops called Hitler's buzzsaw and Allied soldiers described with words Brenner didn't need translated. 1,200 rounds per minute. The mathematics again. Superior firepower from a protected position. The British went to ground immediately. 2 men didn't make it to the crater. Brenner saw them fall, the rest dragging them into cover. The section stayed pinned for 3 minutes, then withdrew back toward the ruins, using smoke grenades to obscure their retreat. Brenner nodded. Exactly as expected. "They'll call for artillery now," one of his gunners said. "Let them." Brenner gestured at the walls surrounding them. "We'll be here when they're done." The morning settled into familiar routine. Occasional rifle fire from the British positions. harassing shots that sparked off the concrete or whined away into the distance. Brenner's squad rotated watch, ate cold rations, made jokes about British marksmanship. One of the younger soldiers asked if they'd be relieved soon. "Why would we need relief?" Brenner replied. "We have ammunition, water, and walls that won't fall down. The British have a beach they can't leave and a schedule they can't keep. Who needs relief?" The laughter was easy, comfortable. The kind of confidence that comes from being proven right repeatedly. Brenner had seen attacks fail before. He'd seen what happened when infantry tried to assault fortified positions without overwhelming superiority. The Atlantic Wall wasn't invincible, no defensive line ever was, but it didn't need to be invincible. It just needed to delay, to bleed, to make every meter cost more than the enemy could afford. That afternoon, the British tried again. And that's when Brenner saw the tank with the dustbin. Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the story. 14:30 hours. The British infantry came forward again, moving with the same cautious discipline as before. Brenner watched them advance through the firing slit, mentally calculating ranges and angles. 200 meters, 150. His machine gunner tracked their movement, waiting for the order. Then something else appeared behind them. A tank. Churchill model. Brenner recognized the silhouette immediately. British heavy infantry tank, well armored but slow. Respectable threat in open combat, but not particularly concerning against fortified positions. Tank guns were designed for penetrating armor, not concrete. They'd pepper the bunker with high explosive rounds that would chip the walls and make noise, but ultimately accomplish nothing. Except this tank looked wrong. Brenner squinted through the firing slit, trying to understand what he was seeing. Where the main gun should be, the long barrel that marked every combat tank he'd ever encountered, there was only a short, stubby tube, barely longer than the turret itself. The proportions were completely wrong, almost comical. "What is that?" his loader asked, leaning closer to the firing slit. The tube was massive in diameter, far wider than any tank gun Brenner had seen, but ridiculously short. It protruded from the turret like someone had sawn off a proper gun barrel and welded on industrial piping as a replacement. The whole assembly looked makeshift, improvised, like field modification done by engineers who'd run out of proper equipment. "It looks like a trash can," another gunner said. Someone laughed. Then another soldier. Within seconds, the entire bunker crew was grinning. "A dustbin," the loader said, pointing. The British mounted a dustbin on their tank. The observation was perfect. That's exactly what it looked like. Some enormous metal cylinder that belonged in a factory or scrapyard, not on a combat vehicle. The absurdity was striking enough that Brenner found himself smiling despite the tactical situation. "Maybe they ran out of real guns," one soldier suggested. "Maybe it's for intimidation," another replied. "We're supposed to be so frightened by the strange appearance that we surrender." More laughter. The tension that had been building since the British advance began released suddenly. Combat was stress, fear, split-second decisions that determined who lived and died. But this was just ridiculous. Some British engineer had apparently decided that what their tanks needed was oversized plumbing fixtures. The tank continued forward, its tracks grinding over broken ground, 80 meters from the bunker, close enough that Brenner could see the details clearly. The stubby tube, the way it didn't extend properly beyond the turret, the whole ungainly appearance of a weapon system that looked like it had been assembled incorrectly. "Should we engage it?" the machine gunner asked. Brenner hesitated. The tank's armor would stop machine gun fire easily. They'd need anti-tank weapons to disable it properly, and those were positioned in adjacent bunkers covering different approaches. But the tank wasn't advancing aggressively. It had stopped, turret rotating slowly. "Wait," Brenner said. "Let's see what this dustbin actually does." The turret continued its traverse until the stubby tube aligned directly with their position. The loader was still chuckling, shaking his head at the absurdity. Then the weapon fired. The sound was wrong. Not the sharp, violent crack of a tank gun, the distinctive report that Brenner had heard hundreds of times, the sound that meant armor-piercing shot tearing through air at velocities that broke the sound barrier. This was a deep, hollow thump, muffled, almost soft, like someone striking a massive drum wrapped in heavy cloth, the kind of sound that didn't match anything in Brenner's mental catalog of weapons effects. What was... The loader started. Brenner saw it then, something arcing through the air. Not the invisible trajectory of a high-velocity shell, but something slow enough to track visually. A large, cylindrical object tumbling end over end in a lazy parabola, clearly visible against the gray sky. It looked exactly like what they'd called it. A flying dustbin. The laughter died. Not because anyone understood what was happening, but because the wrongness of it registered suddenly. Weapons didn't behave like this. Tank guns fired shells that moved too fast to see. This thing was floating through the air slowly enough to watch, tumbling awkwardly, its flight path visible from launch to... "Down!" someone shouted. But there was nowhere to go. They were in a bunker, protected by 1 meter of reinforced concrete, the safest place on the battlefield. The cylinder completed its arc and struck the bunker's front wall, just left of the main firing slit. For a fraction of a second, nothing happened. Then the world ended. The explosion wasn't like anything Brenner had experienced. Not the sharp crack of artillery. Not the metallic impact of tank shells. Not even the sustained blast of aerial bombs that he'd endured during air raids. This was different. The sound came from everywhere at once, a deep, crushing detonation that didn't just hit the bunker, but traveled through it, through the concrete itself. Brenner felt it in his bones before he heard it, a pressure wave that moved through solid material like a shock wave through water. The wall didn't crack. It didn't chip or fracture or show the kind of progressive damage that artillery caused after hours of sustained bombardment. It collapsed. 1 meter of reinforced concrete, the thickness that had protected them through 18 months of combat, that had stopped every shell and bullet the enemy had thrown at them, simply ceased to exist as a structural element. The explosion traveled through the concrete matrix, finding every microscopic flaw, every point where aggregate met cement, every interface between concrete and steel reinforcement. The blast wave propagated through the material faster than the structure could respond, creating pressures that exceeded what the concrete had been designed to withstand. The front wall folded inward, not slowly, not with the grinding reluctance of a structure resisting failure. It collapsed with the sudden finality of something that had stopped being a wall and become rubble. The firing slit, the narrow opening that Brenner had been looking through seconds earlier, disappeared. The machine gun position disintegrated. The massive concrete blocks that formed the wall's facing simply fell apart, individual pieces tumbling inward as the entire structure lost cohesion. Brenner was thrown backward. He didn't feel himself move. One instant he was standing, the next he was on his back against the rear wall, lungs empty, unable to breathe, unable to process what had just happened. The shockwave had picked him up and hurled him 3 meters like he weighed nothing. His ears weren't ringing. They were silent, completely, utterly silent, as if sound itself had stopped existing. Dust filled everything, thick, choking clouds of pulverized concrete that turned the air solid. Brenner couldn't see, couldn't hear, couldn't understand why he was on the ground or why his chest wouldn't work, or why the light coming through the firing slit had disappeared. He tried to inhale and got concrete dust, coughed, tasted blood. His vision cleared slightly, just enough to see that the bunker no longer looked like a bunker. The front wall was gone, not damaged, not cracked, gone. Where there had been 1 meter of reinforced concrete, there was now a massive opening filled with rubble and dust and collapsed material that had been load-bearing structure seconds ago. The roof sagged dangerously, its support removed, held up only by the side walls that were themselves fracturing under loads they hadn't been designed to carry. Brenner tried to stand and couldn't. His legs didn't respond properly. He looked down, confused, and saw his loader lying next to him, face down, not moving. A steel reinforcement bar protruded from his back, the same reinforcement that had been embedded in the concrete wall, now transformed into a projectile by the blast that had torn the structure apart. The machine gunner was gone, simply gone. The position where he'd been standing, where they'd all been laughing about the dustbin gun seconds ago, was buried under tons of collapsed concrete. Someone was screaming. Brenner couldn't tell if it was one of his men or himself. The sound seemed to come from very far away, filtered through the silence that the blast had created in his ears. 3 of his squad were buried in rubble. He could see an arm protruding from the debris, a boot. The rest was concrete and dust and the wreckage of a fortification that had been designed by engineers who understood structural loads and blast resistance and every principle of defensive architecture. Except this: the ones who'd been laughing seconds earlier were dead or dying. Brenner's mind tried to process the sequence: the ridiculous-looking weapon, the laughter, the slow-moving projectile, the explosion that had destroyed in 1 second what 18 months of war hadn't scratched, the bunker that had protected them, that had been their fortress, their confidence, their guarantee of survival, had been erased by a single shot from a weapon that looked like a crude joke. The ceiling groaned. Concrete fragments fell. The entire structure was collapsing, no longer stable, the internal supports compromised beyond recovery. Brenner crawled, pulled himself through dust and rubble and the bodies of men he'd served with for 18 months, toward the light, toward the opening where the front wall used to be, toward the British infantry who were approaching now, weapons ready, cautious but no longer pinned down because the bunker that had stopped them was no longer a bunker. It was a tomb. If you enjoy dramatic, jaw-dropping stories, subscribe to WW2 Archives Declassified. Let's grow this channel to 1,000 subscribers. The Fortress Problem. Britain's decision to develop specialized bunker-busting weapons emerged from tactical reality that became apparent during operations from North Africa, through Italy, and into northwestern Europe. German defensive doctrine centered on fortified positions that conventional weapons couldn't eliminate efficiently. Concrete bunkers with walls exceeding 1 meter thickness, reinforced with steel bars, designed specifically to withstand direct hits from artillery shells. The Atlantic Wall represented the culmination of this approach: thousands of fortified positions covering potential invasion beaches, each positioned to provide mutual support and create overlapping fields of fire that would devastate any assault force attempting to advance. British tank guns, even the relatively powerful 17-pounder weapons mounted on Sherman Fireflies, were designed primarily for engaging armored vehicles. Against concrete fortifications, they achieved minimal effect. A 17-pound armor-piercing shell would penetrate tank armor efficiently, but merely chip concrete when fired at bunkers. High-explosive shells were more effective, but still required multiple hits to achieve significant damage, and German bunkers were specifically designed to survive such bombardment. Artillery could destroy fortifications. Given sufficient time and ammunition expenditure, a sustained barrage from field artillery would eventually reduce most bunkers to rubble, but artillery required extensive preparation, consumed enormous quantities of ammunition, and wasn't always available when assault forces needed immediate support. Infantry attacking fortified positions couldn't wait hours for artillery preparation. They needed bunkers eliminated immediately during the assault itself, at the moment when delay meant casualties. Airstrikes were similarly problematic. Bombing fortified positions achieved results when bombers could deliver ordnance accurately. But close air support was unreliable due to weather, coordination difficulties, and the risk of hitting friendly forces. Infantry couldn't depend on air support being available at the critical moment when they needed specific bunkers destroyed to continue their advance. The tactical problem was straightforward. Assault forces needed a weapon that could destroy fortified positions immediately, without waiting for artillery preparation or air support, using a platform that could accompany infantry during the assault and eliminate bunkers on demand. The weapon needed to be mobile, protected against small arms fire, and capable of delivering explosive power sufficient to collapse reinforced concrete structures. The solution Britain developed was the AVRE, Armored Vehicle Royal Engineers, mounting the petard spigot mortar, a weapon so unconventional that both British troops and German defenders initially questioned whether it was serious military equipment or improvised field modification. The spigot mortar solution. The petard represented a fundamentally different approach to bunker destruction compared to conventional weapons. Rather than attempting to penetrate fortifications through kinetic energy or shaped charges, the petard delivered massive explosive charges that destroyed structures through blast effect. The weapon was technically a spigot mortar, a launching system where the projectile contained the propellant charge and fired from a fixed rod rather than from inside a gun barrel. This design allowed for projectiles far larger than conventional guns could fire, since the projectile diameter wasn't constrained by barrel dimensions. The petard's projectile was a cylinder 26 centimeters in diameter, containing 18 kilograms of high explosive, roughly equivalent to a large artillery shell or naval depth charge. The weapon replaced the main gun on Churchill tanks that were converted to AVRE configuration. Where a normal tank turret mounted a gun barrel 2 or 3 meters long, the petard installation was barely 1 meter, a stubby tube that protruded just beyond the turret face. The visual effect was exactly what German observers noted. It looked like someone had replaced a proper tank gun with industrial equipment that didn't belong on a combat vehicle. The firing mechanism was simple and robust. The projectile, officially designated the 40-pound flying dustbin by troops who appreciated accurate nomenclature, was loaded onto the spigot rod inside the mortar tube. Firing ignited the propellant charge in the projectile's base, launching the bomb with a distinctive deep thump that was immediately recognizable to anyone who'd heard it before. The projectile arced through the air slowly enough to be visible in flight and detonated on impact with the target. The effective range was approximately 80 to 100 meters. Beyond that distance, accuracy degraded rapidly, and the arcing trajectory made hitting specific targets difficult. This limitation was deliberate. The weapon was designed for point-blank assault work, where the AVRE would drive directly toward fortified positions and engage them at ranges where missing was nearly impossible. The mathematics of demolition. The petard's effectiveness against fortifications came from delivering concentrated explosive force against structures that were strong in some directions, but relatively weak in others. Reinforced concrete fortifications were designed to resist penetration from the front, the direction from which enemy fire would typically arrive. German bunkers had frontal armor that could withstand direct hits from artillery shells, with walls 1 meter thick and reinforced with steel bars embedded in the concrete matrix. This construction made them nearly immune to conventional tank guns and difficult to destroy even with sustained artillery bombardment. But concrete structures were vulnerable to blast overpressure that traveled through the material itself rather than attempting to penetrate from outside. When the petard's 18-kilogram warhead detonated against a bunker wall, the explosion created a shockwave that propagated through the concrete, causing internal fracturing and structural failure. The reinforcement bars that strengthened the concrete against penetration couldn't prevent this blast effect. The entire wall would fail as the concrete fractured under forces that exceeded its structural limits. The result was what Brenner had witnessed: total structural collapse from a single hit. The Normandy Proving Ground D-Day operations on June 6, 1944, provided the first large-scale combat test of AVRE capabilities. The results validated the concept decisively and shattered German defensive doctrine in the process. The Atlantic Wall fortifications covering Normandy beaches represented exactly the kind of defensive positions the AVRE had been designed to defeat. concrete bunkers with interlocking fields of fire positioned to devastate landing forces, protected by minefields and obstacles that would channel attackers into predetermined killing zones. German commanders were confident these defenses would inflict catastrophic casualties on any invasion force, buying time for reinforcements to arrive and potentially throwing the invasion back into the sea. British assault forces included specialized armor units, the 79th Armored Division's Funnies, that deployed various modified tanks for specific tactical roles. Among these were AVREs equipped with petard mortars, tasked with eliminating fortified positions that would otherwise halt the advance off the beaches. The AVREs went ashore in the first waves, advancing with infantry toward the fortified positions covering the beach exits. German defenders opened fire from bunkers that had been positioned to provide interlocking coverage, creating fields of fire that conventional assault methods couldn't penetrate without massive casualties. The AVREs identified priority targets, bunkers blocking critical routes, positions threatening advancing infantry, fortifications that artillery couldn't suppress effectively. At distances ranging from 60 to 100 meters, the AVREs fired their petard mortars. The flying dustbins arced toward their targets with trajectories visible to both attackers and defenders, tumbling through the air before impacting bunker walls with explosions that German troops later described as feeling like earthquakes. Bunkers that had been designed to withstand prolonged bombardment collapsed from single hits. Firing slits disappeared as walls fractured and caved inward. Positions that would have required extensive artillery preparation or prolonged infantry assault were eliminated in seconds. The tactical impact was immediate and profound. Beach exits that German defenders expected to hold for hours were cleared in minutes. Infantry that would have been pinned down by bunker fire advanced rapidly behind AVREs that eliminated strongpoints systematically. The Atlantic Wall fortifications that were supposed to make invasion impossible proved vulnerable to weapons that delivered blast effects conventional guns couldn't match. The psychology of collapse. German troops defending fortified positions understood that concrete walls provided protection against most weapons. Bunkers were supposed to be safe places where defenders could fight from cover, protected against small arms, resistant to artillery. The petard violated that assumption completely. When a flying dustbin hit a bunker, the structure simply ceased to exist. Walls collapsed, roofs caved in, firing positions disintegrated. Defenders inside were buried in rubble or killed by blast waves traveling through the structure itself. German soldiers learned quickly, when AVREs appeared, remaining inside bunkers meant certain death. The fortifications that were supposed to protect them became traps that ensured they'd be killed when the petard rounds arrived. This realization fundamentally changed defensive tactics. Troops began abandoning bunkers when AVREs approached, preferring to take their chances in the open rather than waiting to be buried alive when their positions collapsed around them. One British after-action report noted, AVREs proved invaluable in reducing fortified positions. Bunkers that resisted conventional tank fire and required extensive artillery preparation were destroyed with single petard rounds. The weapon's psychological effect on enemy troops was substantial. Defenders frequently abandoned positions when AVREs approached rather than waiting to be engaged. German reports were more blunt. A regimental commander reported, British engineer tanks mounting large-caliber demolition weapons destroyed our strongest positions with single shots. Concrete fortifications designed to withstand sustained bombardment collapsed instantly when struck by these weapons. Defensive positions became death traps rather than protection. Troops increasingly refused to remain in bunkers when these tanks approached. Another company commander was more explicit. Remaining in concrete bunkers when British demolition tanks approach is suicidal. The weapons they employ destroy our strongest positions instantly. Troops understand this and increasingly refuse to remain in bunkers when these tanks are present. Fortifications that were intended to protect our forces have become traps that ensure casualties if occupied when attacked. Recommend withdrawal from fixed positions when British engineer tanks are identified, even though this violates defensive doctrine. The assessment represented fundamental failure of German defensive strategy. The Atlantic Wall and subsequent defensive lines had been constructed around the assumption that fortifications would protect defenders, allow them to inflict disproportionate casualties on attackers, and enable outnumbered forces to hold positions against larger enemy formations. AVREs violated every element of this calculation. Fortifications didn't protect defenders. They created confined spaces where troops would be killed when structures collapsed. Casualties were disproportionate, but in the wrong direction. Defenders died while attackers survived. Small forces couldn't hold positions against larger formations when their fortifications could be systematically destroyed in seconds. German doctrine had prepared for conventional siege warfare. Artillery duels, sustained bombardment, gradual degradation of defensive positions over hours or days. It had not prepared for bunkers being erased in single shots by weapons that looked like improvised jokes. By the end of June 1944, German forces across Normandy understood the new calculus. Concrete walls were no longer shelter. They were coffins waiting to be sealed. The Atlantic Wall reconsidered. By July 1944, the Atlantic Wall's failure was no longer theoretical debate among strategists. It was documented reality written in collapsed concrete across hundreds of kilometers of French coastline. German High Command had invested years of labor and enormous material resources into constructing fortifications that would make Allied invasion prohibitively costly. Millions of cubic meters of concrete, thousands of bunkers. Defensive positions designed by engineers who understood structural loads, blast resistance, and every principle of military architecture that had governed fortress warfare for centuries. All of it rendered obsolete by a weapon that took less than 2 years to develop and could be operated by a crew of 6. The strategic implications extended far beyond Normandy. Every fortified position Germany had constructed, from the Atlantic Wall to the Gothic Line in Italy to the Siegfried Line defending Germany's western border, was now vulnerable to the same tactical solution. Concrete fortifications that had been considered permanent defensive assets became liabilities that consumed troops and resources while providing illusory protection. The mathematics were unforgiving. A single AVRE carrying 30 petard rounds could eliminate 30 bunkers in a single engagement, more destructive capacity than an entire artillery battalion firing for hours. The weapon system was mobile, protected, and effective at precisely the ranges where bunkers were most dangerous to conventional infantry. German forces attempted countermeasures. Anti-tank guns were repositioned to cover approaches to defensive positions, with orders to prioritize any tanks displaying the characteristic stubby mortar tube. But AVREs typically advanced with infantry and supporting armor, making it difficult to engage them selectively. Destroying one AVRE often required exposing anti-tank positions to fire from multiple British tanks, a trade that German forces, already outnumbered and outproduced, couldn't sustain. Some units attempted to concentrate fire on AVREs during their vulnerable reload period, when crew members were exposed outside the turret loading the massive cylindrical projectiles. This achieved occasional successes. AVREs were lost to small arms fire or artillery during reload, but AVRE crews learned quickly, conducting reloads behind cover or while protected by smoke, making them difficult targets even when exposed. The deeper problem was that no tactical adjustment could address the fundamental issue. Fixed fortifications were no longer viable defensive assets when the enemy possessed weapons specifically designed to eliminate them instantly. The shift in military logic. The AVRE represented something more significant than a successful weapon system. It embodied a shift in military thinking from overwhelming force toward precision problem-solving. Traditional approaches to bunker destruction relied on applying massive firepower until fortifications surrendered to accumulated damage. artillery barrages that lasted hours, aerial bombardment that dropped tons of explosives, siege tactics that accepted prolonged timelines and enormous ammunition expenditure. The petard inverted this logic. Rather than overwhelming fortifications with sustained firepower, it solved the specific engineering problem of how concrete structures failed. Rather than attacking fortifications the way they were designed to be attacked, from the front with penetrating weapons, it exploited their fundamental vulnerability to blast overpressure propagating through the material itself. The weapon looked ridiculous because it didn't need to look impressive. It needed to deliver 18 kilograms of high explosive to a specific point on a concrete wall at ranges where accuracy was guaranteed. The stubby barrel, the ungainly proportions, the slow-moving projectile, all were consequences of engineering decisions that prioritized effectiveness over aesthetics. German soldiers had laughed because the weapon violated their expectations of what threatening weapons should look like. Long barrels meant velocity. Velocity meant penetration. Penetration meant lethality. The petard ignored this logic entirely and achieved lethality through different principles. This represented the broader trajectory of modern warfare. Victory increasingly belonged not to forces with the most firepower, but to forces that could identify specific tactical problems and engineer precise solutions. The AVRE didn't make tanks obsolete or artillery unnecessary. It filled a gap that conventional weapons couldn't address efficiently. Legacy of the Flying Dustbin. Karl Brenner survived the war. He spent 3 years in a British POW camp, returned to Germany in 1947, and worked as a construction engineer for the next 30 years. He helped rebuild some of the same fortifications he'd once defended, though as civilian structures rather than military installations. He never entered a concrete bunker again. When asked about his war service, he would describe the moment the Flying Dustbin hit his position. The laughter that turned into death in seconds. The realization that everything he'd trusted, concrete, doctrine, the promise of protection, had been invalidated by a weapon that looked like industrial scrap. "We thought fortifications meant safety," he said in an interview decades later. "We thought concrete walls made us invincible. Then the British showed us that concrete was just another material that could fail. That doctrine was just assumptions waiting to be violated. That the strongest fortifications in Europe could be defeated by engineers who understood the problem better than we did." The AVRE served throughout the Northwest Europe campaign, from Normandy to the Rhine crossing. The weapon that German defenders had mocked became the symbol of their defensive collapse. The proof that modern warfare belonged to forces that could innovate faster than their enemies could adapt. The Dustbin gun had looked ridiculous. It had also won the war. Don't just watch, subscribe. Help WW2 Archives. Declassified hit 1,000 subscribers.